The next covalent structure we're going to show here today is made of one oxygen and two chlorines. Just like before, we write out each atom separately. One oxygen and two chlorines. Oxygen's in group 6, so it gets 6 little valence electrons. It doesn't matter which sides have the single, as long as they're in there. Chlorine, I'll go ahead and do it in red here so we can see them separately, is in group 7. It should have 7 little electrons around the outside edge. And again, it doesn't really matter where we put the single, as long as we have 3 pairs and 1 single. So we have all 7 valence electrons for chlorine shown in that Lewis structure. Oxygen has 2 places to bond. Each chlorine only has 1. So that's my clue that oxygen is in the middle, has most bonding sites. The chlorines are each going to share their single electron with one of the single electrons from the oxygen. So I get one on this side and one on this side. So I'm sharing a pair there and a pair there. Now each atom has 8 electrons some of the time and is more stable. I'll make the drawing more neat by just putting oxygen with its lone pair of electrons hanging out there attached to a chlorine here. Again, I'm not going to get lazy and forget these extra electrons on chlorine. They play a role in the behavior of the molecule. We don't want to lose them. And I get a great structure. Notice there's kind of a bent shape to this. It's not straight because these electrons on the oxygen are shoving these bonds a little bit away. That shows up in our model that we'll look at in just a minute. The name of this compound is oxygen dichloride. For di meaning we have 2 chlorides. We don't start with mono, even though we have 1 oxygen. I don't know why chemists decided on that, but we don't use mono on the first word. Now I'll show you the structure that comes out of this as well. Using our model kit, with red representing the oxygen and green representing my chlorines, oxygen has 2 available bonding sites. Each chlorine has 1 available bonding site, and they're stuck together in this bent shape. And we can see, even though the electron pairs aren't shown on that red atom, that they're pushing these bonds downward at an angle, and we get this bent shape. This looks a lot like water. Water has a very similar shape, H2O instead of OCl2.